In this video, we're going to talk about integers. So first, let's go ahead and introduce what they are, and then we'll look at operations on integers. So before I introduce integers, I want you to recall whole numbers. So take a second, think back. What are whole numbers? And if you have to go look it up, I understand. But whole numbers are the numbers starting from 0 and then start on the counting numbers. So different from the counting numbers simply because they include 0. Okay, so integers, let me go ahead and define integers. So integers are positive and negative whole numbers. All right. If I were to list them out, just like how I did the whole numbers above, I would actually have to go the dot, dot, dot at the end in two different directions because there are the negative numbers. So -3, -2, -1, and then 0, 1, 2, 3, and then dot, dot, dot in both directions. So it's going to positive infinity and negative infinity. And the integers have a direct tie to the visualization of the number line. So when we draw a number line, the little tick marks we draw on the number line are the integers. So here, -3, 1, 2, 3, 4. Those are the integers. Okay, so couple things that I want to mention about the integers, some terminology we should know before we jump into the operations. First is the concept of opposites. So when you say, what is the opposite of 2? When you're talking about integers, the answer would be -2. Why? Because 2 and -2 are on opposite sides of 0, and they're the same distance from 0. Also, 2 and -2, when you add them together, adds up to 0. That's not a coincidence. All opposites do that. Okay, and then before we, again, get into the operations, I just want to kind of briefly discuss applications of integers. There are so many. I would say that some of the more obvious ones would be finance. And I would even go like basic, like personal finance, right? The idea that positives are numbers that are in our benefit, negatives would be numbers that are debts, okay? Or if you're talking about like a business that is in the black means it's a business that's making profit. A business that's in the red is a business that is losing money. Okay, so finance would be a great example of integers. And then temperature would be another really great example of where we could use integers, right? We all know that there's negative temperatures below 0 degrees, and that's representing how cold it is, the absence of warmth, and so forth. Okay, so let's move into visualizations. Now we're going to focus on two major visualizations. The first is the number line. It's kind of the most natural of them simply because the integers appear on the number line. So it's an easy visualization, okay? And then we're going to look at the chip model or some sort of manipulative. We're going to focus on adding and subtracting for both of these. And then I'm going to do a separate video for the multiplying because multiplying and dividing are way more complicated with these visualizations. Okay, but the adding and subtracting are pretty straightforward. We can get through them pretty quickly. Okay, so before we do the adding and subtracting on the number line, just really quick, when we talk about adding on the number line, we typically think move right. And subtracting on the number line, we think move left. I should have wrote subtract to be consistent with the word add. Okay, that's fine. Let's look at a couple examples with this, just kind of basic idea. So let's say we want to do -3 plus 5. So the first number is always the number we start with, our starting point. Okay, so I'm going to draw my number line here. And okay, so there we go. I went from 5 to -5. Okay, so I'm going to start with -3. So -3 would be 1, 2, 3 right here. There's -3. And then from -3, I'm going to move right 5. So 1, 2, 3, 4, 5. And that lands me at +2. And there we go. That's the answer. Yay, we're amazing. Okay, let's try another one. Let's try 4 minus 6. Okay, very exciting there. Drawing my number line again. Okay, so in this one, we're starting at 4. And then minus means subtraction, so we're moving to the left. 1, 2, 3, 4, 5, 6. And that lands me at -2 this time. So exciting. All right, so there we go. The basics of the adding and subtracting. Okay, now when you add a negative, that changes things a little bit. Like let's say I want to do 7 plus -6. By the way, I do want to note the book doesn't actually put parentheses around the negative. It kind of uses a special like negative sign that makes it very distinct. But I'll use parentheses just because I want to make sure you clearly see that there's a negative on that number. Okay, so 7 plus -6. All right, so on my number line here, I'm going to actually kind of lopside it a bit here. 0, 1, 2, 3, 4, 5, 6, 7, 8. And then there's -1. Okay, so starting at 7. And then normally when we see plus, we're thinking, okay, we move right. But what happens is the negative causes us to go the opposite direction. So negatives make us move the opposite way. Okay. So when I do 7 plus -6, normally I do 7 plus, and I'm like, oh, cool, I'm going to move to the right. But no, the negative makes me instead move to the left. 1, 2, 3, 4, 5, 6. And that lands me at +1. Cool. All right, so let's do one more. Just make sure we feel good about that. Let's do -2 plus -3. And if you want to pause the video and give it a shot, just so you feel good about yourself, that's great. I don't know why I did that number line so big. Okay. All right. So I'd start at -2 and I see the plus sign. And then I see the negative following the plus sign. So I'm like, ah, I'm going to move left. Just kidding. Not going to move right. And I'm going to move left 3, landing me at -5. All right. Lovely. Now, I want to take a second and actually use what we just saw to kind of sum up how to approach addition with negatives. Okay. So in this example, we'll just kind of point out some obvious things. We have a -2, we added a -3, we ended up with -5. Okay. So we had two negatives and it added up to be a negative. Over here, We started with a positive 7, we added a negative 6, and we ended up with a positive 1. Okay, so we had a positive and a negative, and we ended up with a positive number. Okay, now here, this was technically a subtraction, okay, because I was just kind of showing the basics of the number line moving. All right, we're about to do some more subtractions here in a second, okay? But with the 4 minus 6, we'll talk about that. So we're going to skip that because I want to focus on addition for a second here. Okay. All right. So here we go. Another one. We have a negative plus a positive, and it gave me a positive again. Okay. So at the moment, I see that when I've had a negative and a positive, meaning like they've had opposite signs, I've come out positive both times. That's not always the case. For instance, if I had or started with, let's say, 2 plus negative 4. If I did this one, okay, so I'm starting at 2 and then thinking I was going to move right, but then the negative makes me move to the left. So I'm going to go left 4. 1, 2, 3, 4. And that lands me at negative 2. Okay, so in this example, I had a positive and a negative, and it gave me a negative. Okay, so the question is, how do I know that the result is going to come out negative, right? Versus over here when they came out positive. Okay, and the answer is it depends on which number is bigger. All right, so let me go ahead and write the rules then. So first rule is if we have a same sign for both of the numbers. So if we add 2 integers with the same sign, you sum the numbers and their sign carries into the answer. So just to solidify that, if I was doing negative 3 plus negative 4, both numbers are negative. So the answer is going to be negative, and then I'm literally going to sum them. I'm literally going to do 3 and 4. 3 plus 4 is 7, so negative 7. Okay. If I had let's see, negative 10 and negative, oh, I guess I didn't really give us a more exciting number, negative 12. Same thing, right? Because both numbers are negative, they're going to add up. We're going to actually sum them, and then they're going to give us a negative answer. Okay. And if you think about the number line, basically you're just going more towards the negatives, already starting in the negatives. Okay, great. So there is how we would add with the same sign. Now, I didn't do positives because I feel like we've kind of talked about that. Okay, so when you add 2 integers with opposite signs, okay, now here's where it's different. Now, the book takes 2 separate rules to write this, but it can be done in one rule. So if you add 2 integers with opposite signs, you take the difference, meaning you subtract them, and the sign of the answer is the sign of the bigger number. All right, let's do an example. So let's say we have negative 4 plus 7. Okay, so one number is negative, the other one is positive. So first thing I'm going to do is subtract the numbers, take the difference. So 7 and 4, that difference is 3. And because the bigger number is positive, the answer is positive. Since 7 is bigger than negative 4, the answer is positive. Let's say we do 6 plus negative 11. Okay. 6 is positive, 11 is negative. So we are going to subtract them. So 11 minus 6 is 5. And because the bigger number in this case, the 11 is negative, the answer is negative. And that is how you approach adding integers. Okay, this is the basic rule. Book does a little bit different. And if you like how the book does it, that's fine. It's a good written way. They just use kind of like a formula, like they write A and B in a way to kind of express it like that. I just kind of use words. All right, now let's do some subtractions. We did one. Let's come back and do another one. Let's say I want to do negative 4 minus 7. So on the number line, start over here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, that works out so well. Okay, so here, negative 4 is 1, 2, 3, 4 right here. Here's negative 4. And then I see the subtraction. I'm going to move left 7. 1, 2, 3, 4, 5, 6, 7. And that lands me at negative 11. Lovely. All right. Let's go ahead and try a subtraction with a negative, like 2 minus negative 4. So just like above when we were doing addition, the negative is going to cause us to go the opposite direction. Okay, so I'm going to start at 2. And then normally I see the subtraction, I'm going to go left, but the negative says, go the opposite way, go the right. And instead I move right 4, which lands me at positive 6. So exciting. All right. And let's do one more. Negative 3 minus negative 7. If you want to pause me and do that yourself, great. Go for it. Oops. I guess that doesn't matter. 2, 3, 4, 5. Okay, great. So I'm going to start at negative 3, which is right here. I see the subtraction. I think I'm going to go left, but nope. Can I actually go right? 7. 1, 2, 3, 4, 5, 6, 7. And that lands me at 4. Wonderful. Okay, so those are the basic rules for adding and subtracting on the number line. Now, just like above, where I kind of summed up what happens when you have addition, let's kind of discuss what happens when we have subtraction, okay? So like up here, when I had negative 4 minus 7, I ended up with negative 11. I'm noticing that 11 is the sum of 4 and 7. And if I kind of thought of my addition rules, it almost seems like they're both negatives, which does kind of work because we can think of subtraction as a negative. In fact, that is the first rule. I guess I'll call it rule number 3. So subtraction can be rewritten as the addition of a negative. Let's do an example. So let's say I have 5 minus 10. I can rewrite that as 5 plus negative 10. They're the same thing. On the number line, if I drew them out, they're going to look exactly the same. They're going to both move to the left, starting at 5 and ending at the same spot of negative 5. Okay, so the idea is these two statements are equivalent. We can rewrite a subtraction as plus a negative. Okay. And then rule number 4, the subtraction of a negative. Oops. The subtraction of a negative can be written as an addition. Or in other words, if you have 1 minus -7, that's the same thing as 1 plus 7. All right, we can rewrite the subtracting of a negative as an addition. They behave the same way. If I drew these out on the number line, they're going to look exactly the same. I'd start at 1 and then I end up moving right 7 and landing at 8. Okay, that's how it would look. Okay, now, there are such cute little ways to remember these things, and I encourage you to use whatever cute way that makes sense to your brain, but those are the basics of adding and subtracting negatives. Okay, and the basics of the number line. The number line kind of allows us to explore a way of writing those rules out for adding and subtracting negatives. Okay, the second visualization method, which I think is actually really good, uses this idea called chips. Okay. That's how the book refers to them. For us, and here, let me go ahead. I'm going to change this to black for the purposes of this. So for us, a black chip, like a black circle, okay, that is going to end up representing a positive number. Wow. That's an S. A positive number. And a red chip would end up representing a negative number. Now I'm not going to fill them in like this every time, like where I kind of like scribbled them in. I'm going to do that. Just so we're clear. That was just me kind of being cute. If I had the actual manipulative, obviously they'd be solid, but you know, I'm a little bit lazy. So when I draw these, I'll switch between black and red, and that's about all as exciting as I'm going to get. But they're just going to be open circles. Okay, so let's just do an example. Oh, before we do that, sorry, hold on, before we do that. If you take a black chip and you add it to a red chip, a black chip plus a red chip, they end up canceling out. Okay, they zero out. A black chip plus a red chip. So what it's really representing is the positive number 1 and the negative number 1. That's what this represents. Positive number 1 plus negative number 1. And those happen to be opposites, and therefore they equal 0. Okay, great. So just so we're clear, black and red chips, they cancel out. Okay, now that we got that all out of the way, the rules, let's try it. So let's go ahead and do -5 plus 2. Okay, so to represent this, I'm going to start with -5. We start here. And I have 2, 3, 4, 5 red chips. Okay. And then I want to add 2 black chips to it. Okay, so here, and sorry, they usually like have this like circle that represents the universe right now, what's going on in our problem. Okay, so 5 red chips, and then I'm going to add 2 black chips to it. And what happens is these chips end up canceling out, right? Because they neutralize, they become 0. And what I'm left with is 3 red chips when I'm done. So that would represent the number -3. And there you go. That's how you would model that with chips. Okay, let's try another one. Let's say I have 4. Sorry. I immediately switched to writing the negative number in red. My brain. Okay, -4 plus -3. There we go. All right, so here, my little universe. All right, so I have 4 red chips for the -4. 2, 3, 4. I add 3 more red chips. Nothing cancels out, so this is just -7. Cool. All right. Let's make it more exciting. With subtraction ends up removing chips. Okay, so addition, obviously, we add chips together and then blacks and reds kind of neutralize each other, right? So we end up kind of seeing, what happens, what's remaining once they've neutralized each other and became 0. with subtraction, we remove chips. So when I have -6, like -2, something like that, okay? That means I'm starting with 6 red chips, and I'm going to remove 2 red chips. That's what that says to me. Take out 2 red chips. So if I take out 2 red chips, I'm left with 4 red chips. So that's how we do -6 minus -2. Okay, now what if we have something like -6 minus 2? Okay, different scenario this time. Because in this case, we start with 6 red chips, but the problem is it's asking me to take away 2 positive chips. It's saying take away 2, and I don't have 2 black chips to take away. So above here, I was taking away 2 red chips, right? But this is saying I'm taking away 2 black chips. So I have to introduce 2 black chips. I have to actually bring them in here and neutralize them. So I'm going to add 2 black chips and 2 red chips. So the idea is these 2 are technically representing 0 because they cancel each other out, right? They eliminate each other. So once I've done that, now I can take away 2 black chips, and I am left with 8 red chips. And that's how we handle something that, is missing from what we're working with. Okay. Okay, let's just do one more example. Let's do, how about we have 5 minus -3. Okay, so 5 means I'm starting with a positive 5. And I have 5 black chips. Okay, and then this is saying I need to take away 3 red chips, but I don't have 3 red chips. So I have to introduce 3 red chips. Okay, here. So there's 3 red chips, but now I have to cancel out the fact that I introduced 3 red chips. Okay, so they call this a put and take. The idea is we're putting in what we need and at the same time taking it away. Okay, so I'm putting in 3 red chips, but I'm neutralizing them so that if I were to say, oh, wait, hold on, these things all cancel with each other, right? All of these cancel out. I'm still only working with 5 chips. Okay, but the whole point of this was so that I could take these red chips away. Boom, they're gone. All right, and what I'm left with is 8 black chips, or positive 8. And there you go. That is how the chip model works.